Okay, so hello everyone, and welcome to another awesome stream. And today we'll be learning a lot of interesting things. So my name is Sayam Pathak, and I'm a CNCF ambassador, working as director of technical evangelism at Civo, building the next gen cloud platform with amazing services and community behind it. And today we will be talking about FuseML, MLOps, and a lot of other things, which I'm excited that Alex, who is there, who you can see on the screen, will be talking about. So, few things first. So, if you are new to the channel, please care to subscribe because that's what keeps me going. I'm very close to, I think, 4,000 subscribers, 100 or 150 away. So, I think you can do that. So, definitely do it. And after that, you can see my Twitter handle. You can follow me for all the tech things that I do and all the streams as well. And yeah, please be nice to each other in the streams, and do not post anything offensive. Obviously, there's a moderator who is moderating the chat, and anything which is not right for the stream will be removed. So please be nice to each other, as just as you in any other live stream as well. I know you are awesome people, awesome cloud native folks, just here to learn, so which is amazing. And with that, what we are going to do is today I'm joined by Alex. You can see on the screen a very amazing person from SUSE, and I actually had multiple conversations previously as well with him. We have been working together on a couple of items before as well, so I know him pretty well. And today will be, I mean, it'll be really, really interesting, and you will learn a lot of things. Data engineer, if you are a DevOps, if you are from machine learning side, if you are from AI side. So in from any scenario or any persona that you are a part of, you will be definitely learning something new today. And there's an amazing demo that is actually planned. So it's basically the pneumonia prediction from the chest X-ray scan. So you can see like how awesome it sounds, and the prediction thing, and you'll be actually seeing it happening. So that will really be amazing. So please make sure you keep your keep sharing, and keep sharing your learnings from the stream and about that. So let me just put all of you on the screen because you have joined live, so you deserve to be here. Hi Stephen, hi Abhishek, hi Praja, hi Ingin, and hi Salonis. The moderator already joined. Yes, all the resources definitely will be shared, Braja. The demo is basically publicly available stuff, which Alex will be sharing. FuseML is open source project which he will be talking about. So we'll be sharing all the links definitely, and we'll be trying to cover. I saw the agenda, and it's basically really, really cool. We'll be going through MLOps, AIOps, DevOps, then what all these means, how they are different, then why the machine learning operations is actually difficult, and how you can, in which way you can approach these. And then FuseML, what the project is all about with respect to the demo, and its architecture wise, how it works, how you people can be a part of it, how you people can be part of future kind of demos, future learnings, training the models, contributing to the project. So a lot of things are planned for kind of today's session. So I'm really, really, really excited for that. So with that, let's start, because it's nice mention, Saloni, over there. So ask questions live. Let's make it as interactive as possible. So keep your questions coming in, flowing in for Alex, and because it's very interesting domain, right? Machine learning it is. So definitely ask your questions. And you are from DevOps background, you are from cloud native background, and you have always wanted to move or enhance your knowledge to machine learning ops or AI ops. Definitely today is the day where you'll get some guidance, and you'll get some practical knowledge. You'll get some overview of the project, how things are getting implemented, how things are getting worked in this space. So tons of great stuff is being catered for you. So please ask your questions as and when it is coming. We'll try to answer them all. With that, today I'm joined by Alex. Thank you so much, first of all, Alex, for tuning in, giving your time, and sharing your awesome knowledge with the community. So please introduce yourself to the community.
Yeah, absolutely. In the meantime, I started to share my screen. Well, first of all, hello everyone. I'm Alex, Alessandro Festa, but Alex definitely works better. Well, my daily job is a product manager for AI initiative at SuseRancher. Actually, my night job, as I know, is basically coding some cool stuff, at least what I think is cool stuff on GitHub. FuseML is basically a mix of things for me. FuseML is an open source project that we are working with my team, my amazing team. And as every open source project basically is all about contribution, all about sharing, learning, and basically build awesome stuff together. So as basically I'm saying before, feel free to ask me any question. I hope I can answer them, but I'm a product manager, so in case I don't know the answer, basically there would be an awesome user story for my team. And I'm pretty sure they will know how to answer that. So let me start with really short presentation, and during that, jump to the demo that I think that is usually the most interesting part for everyone. So FuseML, open source AI orchestrator for MLOps. But first of all, a really short definition of FuseML. A composable, flexible, reliable, maintainable, scalable, interoperable AI orchestration platform that integrate open source components. Now, it seems like really, really hard to explain what it is, but in a nutshell, basically, it's all about taking your favorite tools, combine them together so that actually you can build, manage, and run your ML lifecycle. And this is exactly what we'll explain how to do so. But to go even further is about, okay, but who does this? Who is responsible for this AI orchestration? That is not the typical orchestration we all talk about. So this is the small agenda for today. First of all, let's define who is the main personas. Who is responsible for the machine learning lifecycle? Then let's go why MLOps is really hard. Harder than what one can think. Why you need a specialized professional set of professionals to do MLOps. And then let's do something. Let's go through the demo. Let's try to solve a practical use case using FuseML, but even learning how to solve the practical use case in the machine learning environment. And then go for some conclusion, like what we learn, how we can contribute to the project if we like it, and etc. So first of all, don't be scared like this nice dog, but let's talk about MLOps, AIOps, DevOps, ops all the way in. So we all know, supposedly we all know a definition of DevOps. I pick up the Wikipedia definition because it's the easiest one. Okay, it's a set of practices that combine software development and IT operation. Pretty easy, right? Everyone now knows what DevOps is. But people speak about AIOps and DevOps. And so one start to be confused, like, okay, what those are different kind of ops, are part of DevOps, what's about? And so let's start from the AIOps. Let's say that, and this is the what if, your need as a DevOps is to automate deployment in a smart way. And with smart way means I'd like to know if a certain workload may be deployed in a certain node before time, or I'd like to know which alerts I should pay attention to it. And I'm using the monitoring fatigue as an example because it's really practical example. I think if I remember right, my Rancher colleagues show OPNI recently that this is a project around that. But actually, the monitoring fatigue is there. We keep adding monitoring, keep adding alerts to the infrastructure. At some point, we have so many of them that we really struggle to recognize which of those alerts are really important to us, because we need to learn over time around our infrastructure, how the infrastructure runs. So the what if is about, can I have a tool that actually learn over time and tell me if something's going on that I need to really pay attention to that? So AIOps is nothing more than DevOps that use AI in the specific of this context. I need an AI-empowered tool. I need a tool that has AI within that. I don't want to learn AI. I don't want to use AI. I just need to have a smart tool that help to remove that fatigue from my job. That's about AIOps. So it's nothing to say with building model, transfer, training, and etc., but it's only about using AI in the current context of your tools. MLOps is a completely different matter. Let's say that your company is developing AI products, like a predictive service to diagnose pneumonias through X-ray chest. and improve the job of radiology specialist. And it requires someone to take care of all the ops stuff, plus the relevant part for the infrastructure, the AI tools, the AI infra, the AI monitoring, the optimization of the workflows, where they run, how they run, the performance, and so on and so on. That's an MLOps. So an MLOps is actually a practitioner, is someone that knows AI up to a point that he knows how to optimize that workflow, but also is an op and is a developer because he has to develop that workload. He has to develop that pipelines, and he has to know how to set up and run those tools. They're specific to that context. So in a nutshell, AIOps and MLOps are just a subset of DevOps. If you put AI in the context of DevOps, then when it comes mostly around the devs, you got the MLOps. When you go more to the operational side, this is where you AIOps. And I'm challenging you a little bit, Sam, because I don't know if you agree with this slide. I put in that security because that is a huge trend that is coming in. We're already observing the security when it comes to DevOps, but within AI, you have two kinds of security challenges that arise. Fairness, biases in the AI models, but also security from AI perspective. You're running smart things that run confident stuff that need to be secure and need to be treated as secure. And that's basically is a sort of sec IT ops or sec AI ops that is actually raising. And I'm glad, I would be more than glad actually to speak in another time about that, because there's a whole thread that is coming in about compliance and how we can make it not just the model fair and avoid biases, but also how we can be more secure and fair when it comes to operational side of AI. So again, nothing new under the sun. It's still DevOps the whole way. It's just a matter of clear the confusion and say, okay, if I'm actually doing AI stuff like we are going to do today, that is an MLOps. But if I'm going to just leverage AI and I don't really care what's behind the scenes, that's AIOps. That is still really, really valuable, but is in a completely different context, more in an infrastructure context. So let's move on a little bit, okay? So don't be scared again. Machine learning lifecycle and why MLOps is hard. First of all, what machine learning lifecycle is, and that will explain why MLOps is so hard. How it works. Let's say you have a use case, and we will go through the use case later. So the first step is you have to scope the use case. Who does the scope of use case? Well, typically this is where the data engineers and the data scientists comes in. We need to predict in XYZ, so we probably need some specialists, the radiologists, the doctors that tell us what they're looking for. We need the data scientist, data engineer to build the data set, to understand the data, start pitching the models, what we need to do, how we need to approach, what kind of mathematical solution we want to approach. So scope is really the first step. And I stress about this because this is super important. It's like something we all knew when it comes to infrastructure. There's no better infrastructure than the one that is well designed at the beginning. If you don't spend time designing your infrastructure, you're going to fail anyways. Same goes for a machine learning project. If you don't design the project at the beginning very well, having a good quality of data and so on, you're going to fail. There's no way. There's a fake matrix, and I say fake matrix because actually it's never been a real and official metric that says that 8 projects in AI out of 10, they never reach out production. Reality probably is different, but nonetheless, that explains you how much it's hard to make AI project. Most of them, they fail because they were not well told at the beginning. So once you got the scope done, you go to the experimentation phase. What's the experimentation phase? The experimentation phase is where your data scientist basically pick up the data set the data engineer is building and try to use a model. They build a model, they do training about the model, they try to experiment up to a point where they have more or less a choice about the approach. They know how to solve the use case. This is typically done locally using specific tools they have and so on. The experimentation phase is really pure dev phase. Once the experimentation more or less is done, actually it's a mix of them, you move to the training phase. So you pick up the model and you train a model against the data you have. that is like, dear mathematical model, you have to learn against this data. So actually you can tell me actually if you are ready to predict something. And that's exactly the same, the last part of the machine learning lifecycle, that is prediction. Okay, I as a model, I'm able to recognize a pneumonia from a normal X-ray chest. And now because of that, if you throw at me a new data, I'm able to actually give you an answer. That's prediction. Or more technical, that is the inference part of the model. You train the model, then you serve it to an inference server. That's the prediction phase. Problem. Sometimes there's a drift, a data or a content drift. What is about? Well, maybe it's your data is quality of the data is changing over time, so your model is not precise anymore, and then you have to come back in experimental phase and hack a little bit the whole stuff. Or maybe there's and this is content drift, or maybe it's data drift, like the model is not precise, it loses precision over time, and so you see that the new data is not recognized as before, so you need to retrain the model over time. That actually is a big hint about how your job as MLOps works. Means, dear MLOps, training is not a one-time action. Is an iterative action. Is a loop. You have to retrain your model from time to time, and you have to have used tools to understand when your model actually is going to degrade. And because of that, you need to come back and eventually retraining or even reevaluate the whole stuff, up to a point where eventually you have to come back to the full experimentation phase because the model is not valid anymore. Something changes, the data changes, the quality of data, the kind of data that is coming in is completely different. So you have to restart almost at the beginning. That's already explained a lot of confusion. Now, what it comes? Well, the first part is all about data engineers and data scientists. They do this part, the training, the experimentation, the scoping. This is where they can really be helpful and they mainly work. But the second part is where you as MLOps comes in, because you are responsible to set up the infrastructure, you're responsible to optimize the infrastructure and understanding when it comes to retraining and so on and so on. And this is actually the challenge you have to face. That's a mandatory area of collaboration. This is where you have to talk to a data scientist, to a data engineer, understanding exactly how they are going to solve that problem, what they require to optimize, what tools they require to understand the model, etc., and set up and manage all the things. There's a lot of effort. And there's a lot of friction, of course. Why? Well, you can imagine that. So let's do something. Let's try to do something that actually can explain and it can solve this configuration. And if there's any question, feel free to drop the question in the chat, or say, if you have any question, feel free to interrupt me anytime. You know me enough that I'm Italian, I never stop talking.
No, that was pretty insightful. First of all, the difference between AIOps, MLOps, and the DevOps, and how all three of them kind of sit together. So you shared a nutshell slide, which was really good, and the security layer overlapping shows that kind of security is everywhere, so we cannot ignore security and in any of the layers that we are working on, starting from the operating system to any model to any project or infra. So at all levels, definitely the security front is there. Then also the scoping, like the scoping of the project is really important, and that is where the most of the AI projects fail, because they're not scoped with a particular aim or goal in mind that they have to achieve and predict. So a specific use case, a specific goal to which then you will be experimenting, training, and predicting in the end. And yeah, that was pretty neat, and I totally understood what the whole idea is.
And you know, but I mean, you know better than anyone. I mean, all us that works in the DevOps area that's why I'm stressing that DevOps, how they are linked together. I mean, you can be an MLOp, but you can be at the same time an AIOp, because MLOp is about the specific of AI, but you keep using smart tools to make your job easier, because monitoring is monitoring. You will keep using Grafana and Prometheus anyways. You will keep using those kind of tools. So that means that if you have Omni from Rancher, for example, to get the alerts when they're ready and when actually they're really relevant, it helps your job. Nonetheless, you keep working as MLOps on the specific of not just the generic module, but on the module on your AI workload. So back to the presentation, let's do something. So I will run a demo. If the demo gods are with me, everything should work. And I will try to do as much as I can multiple persona. Now, because I'm Italian, that should be easy because that's basically what I am as an Italian, multiple persona in one body. So don't be scared. I'm not a psycho, at least this is what my team says, but I cannot guarantee. I see Stefan from my team in the chat before. He can eventually confirm or deny. I don't know, we'll see in the chat. So during the demo, I will do multiple persona. I will act as a data engineer, data scientist in the context of experimentation phase to explain what I need to do, what I'm doing, what I've done. I will be an ITOP developer just to explain when I will get to the inference, to the prediction phase. I will be the operational, the MLOps, mostly to explain how I will optimize the whole machine learning lifecycle. All of those personas, basically, they want to have a single, I'm trying to get control of my mouse, sorry about that. I lost my control of my mouse. I want to basically achieve collaboration, monitoring, measure, optimization, improvement, deploy, training, do it. I want to do it, and I want to do it in the easiest way possible. So let's see how I can do that. First, let me present you the use case. I think this gives you a good sense of how much X-ray chest analysis is super important in the market. Amazon AWS has a dedicated service for that. So literally you can throw your X-ray chest to this service and basically up to 2,000 requests and probably more and etc. And they can basically predict automatically and etc. There's plenty of solution. Converge, that is another great company in the MLOps space, or got something like that. There's plenty of COVID-19, unfortunately for us, bring again this use case. Google ML Cloud AutoML has a similar use case. Kaggle, and I give you Kaggle as a pointer. Whoever want to start with IML, whoever want to start in this space should pay attention to Kaggle.com. Kaggle is just finished to run in the last month, 30 days to machine learning course. I think you can register yourself and do it. That literally teach you everything about machine learning from there. So just using that. So X-ray chest is big things, but what is about? Pretty simple. Someone goes to the hospital, he got an X-ray chest. The image that come out from the X-ray chest is sent to an application infrastructure. This application basically has a model that basically pick up this image, look at the image, recognize the image. In this case, specific pneumonias, the kind of viral or bacterial, but actually it could be any disease in the X-ray chest. Identify the area, eventually you can even highlight the area, and then get a response. The response helps the radiologist to focus immediately on the problem. Now, to give a sense, this has come out from an NHS public report. And last year, there was more than 34 million imaging tests in England in 12 months. And 2.86 million of those were actually just in February 2021. We all know, unfortunately, why. The average results of an X-ray chest, specifically X-ray chest, looking for pneumonia in this case, was 3 days. That's because too many of them, too few radiologists, because it's really complex, and you really need to be sure what you're looking for. You need to recognize what you're looking for, etc. And so, unfortunately, the average is pretty low. I mean, actually, it's pretty good to me, but actually it's pretty low. It's 3 days. 3 days you can save lives. That's why it's super important to have those kind of things. Now, just to clear up, this is your showcase. This is a demo. This is a practical use case. I'm not going to save any life, unfortunately. I'm not going to say that this solution is made. It's just a demo to explain how FuseML can help out. There's plenty already of specialized tools to do that, but that's a well-addressed, well-known problem. Now, this is to give you a sense of how much complex is a problem. At the same time, to put back a smile on your face. Well, on the top of the slide, these are three different X-ray chests. One is normal, one is bacterial pneumonia, the other one is viral. Now, maybe it's because I'm colorblind, I don't know, whatever. I honestly, those three images to me sounds exactly the same. I don't see too much difference in them. I would never be able to actually tell you that there's any disease there. But luckily for all of you, I'm not a doctor. I'm a product manager, so that's enough. Unfortunately, we all know where we live, and so in case you're interested, you can learn to read an X-ray chest in 5 minutes and become a doctor, because on the internet everybody is an expert. And that's real. That's a YouTube video, seriously, where there's this doctor chest X-ray basically explain how to read an X-ray chest. Well, probably it's useful for students. But anyway, that's about how can I explain a computer to do so. So back to the scoping and everything. Means we know the use case. We have a specialist that tell us how to recognize these various differences between the X-ray chest, so we can create a data set. And then once we get the data set, we can create a model. In my case, I will use TensorFlow, and TensorFlow actually will basically go there, try to identify the various differences between them, and tell me, hey, this is normal, this is maybe it's pneumonia, this maybe it's pneumoviral, so you need to really pay attention to them. And finally, serve this to an application so we can use it. So these are the personas, Michael, Sasha, Jean, Alex. Just to remind you that is a team. It's complex because it's a team. And you as a ops, Michael, the MLOps, you have to work with all these teams. And that's exactly what it's all about. The team scoped the project. We just finished to scope the project. Now, Sasha and Jean, the data scientists, data engineers, start to work on the experimentation phase. They work with Michael also because they need to set up the infrastructure. This experimentation phase goes for a while until they are not satisfied. And then at that point, they start training the model. Actually, they're doing, even during the experimentation phase, they train the models. And this basically is an iterative process where they do small optimizations, small changes, changing the models, and so on until they are not satisfied. At that point, they move to a real training. And this is where MLOps comes in, but also they keep working on that because you remember, we can have a content or data drift. So the data engineer kicks in to actually to understand that need to rebuild the data set or change the data set. The data engineer, the data scientist kicks in because eventually you need to understand if they have to switch the model. You as MLOps, you observe the prediction and said, hey, I see that our apps is failing to make the correct prediction, so we probably need to retrain to be more precise. And they all use different tools. Now let's give you a practical example. Let's say that I'm picking up 3 favorite tools for the experimentation phase, 2 favorite tools for the training phase, 1 favorite tools for the prediction. That should be easy. Means you as MLOps, you got 7+ application, and don't forget your Kubernetes. If you count correctly, there was 6 application plus Kubernetes per instance, plus Kubernetes cluster there you have to maintain. You have to write all the integration script between those tools because those tools need to pass data and they need to be triggered one from each other. You need to write all the automation integration to move it from experimentation to test to production. And then you have to optimize and debug everything. That's an unnecessary fatigue. I think you can see that why MLOps is so hard. Because that is exactly for one specific use case. We're speaking about healthcare in this specific case. That it was X-ray chest. What if the same company for healthcare decided that at the same time they are developing a project for, I don't know, analysis of bacterial from blood, from the blood? That's a whole different set of tools. You will do all different things. You have to maintain also that. You keep we are adding more and more and more and more fatigue there. So that needs to be a smart way to do that. And then let's do something. Step 1, what info we need? FuseML. Step 2, let them play together with their favorite tools. Step 3, can we do a smoke test? Just stop at the training, then do some optimization, and finally, hey, let's roll out everything in production and possibly blow out the whole things, typically my laptop. So keep with me. Back into this before I actually jump to the demo, just to clarify things. I will jump to the slide from time to time. So scope, experiment, train, predict. In the context of FuseML, we basically use specific naming convention just to make it things easier. So the experiment phase, this is what we call a code set. Think about the name, code set. So this is everything about coding. We give you an environment where you can code, versioning your models, your data, and so on, so you can use them. The training and prediction phase, this is what we call a workflow. And this is a definition. We will see we have an agnostic way to define a workflow. Like the training will be followed by the prediction, or maybe you will simply stop at the training, and the training will use these specific tools to do the matrix. So the workflow defines your logic against everything. When we will say that we assign a workflow, stick with me, no worries, we will get through it. When we say that we assign a workflow, what we say basically is like we link together the concept, the environment of the data scientist, data engineer with the MLOps scenario all together, so that if someone changes something, is automatically reflected everywhere else. This is the full automation. This is where you remove completely the fatigue. I don't have to think about combine again those things. Whenever you do a change, a small optimization, we will trigger automatically everything else. We will trigger everything else automatically. We get the results. We simply focus on the result there. That means that data engineering data scientists are now part of the whole life cycle. They are part also of the prediction and training because they can access there. And the MLOps are part of the full life cycle. There's no friction anymore. Nothing is like that. And so because everything is dynamically linked. And by the way, using your favorite tools, each one of them can use their favorite tools integrated. Now, of course, we don't support all the tools because this project is being released in June 1st. So it's pretty new. And that's why we're looking for contribution. We're looking for stars on GitHub to make us more, basically to appear more on the GitHub repos and to spread the words about FuseML and how good FuseML is. So let's do something. Again, the lady is pretty scared, maybe, or pretty surprised, like, oh, are you doing seriously? Really? No, don't do that. So first thing first, let's do installation. And can I do an installation if not on Civo? Of course I can. And I'm using Civo because it's the easy way to spin up a cluster. So, okay, I will admit it, I'm pretty lazy. So why I have to spend time to set up a Kubernetes where I can simply log in on Civo, click, and job done? You know, it's easy. Okay, so I already set up everything for myself. So I got K9s on my CLI here with my really new cluster Civo, and everything is set up there. So if everything works right, I should have the same result more or less here, and that everything is okay. So to start with FuseML, it's pretty easy. And I'm going live here. Just let me increase a little bit if I can. Okay. So FuseML has a micro website. Got some delay in my, sorry, GitHub IO works better. Sorry about that. Whoa. Okay, we got a really mini website. Why I'm showing you a mini website? Going really down because we basically have a simple installer for you. I already done that. The simple installer download the binary from the latest version. I'm using a super latest version because I really trust the demo gods. So I just build from source the latest version of FuseML. I like risk, basically. You know, I like to live on the edge. Then you see that everything you have to do is like FuseML installer, then point yourself to the tutorials, and that's it. That's all you have to do. Now, let's do it then. Come here and say FuseML installer. I'm not going to say FuseML installer install because I want to show you how the CLI is complete. So I can literally say, okay, FuseML installer, you can do the info, you can do the install, the uninstall, the upgrade and version. We take care of everything you need on the backend to install. What is about every tool that you like to have. So I would say
Can you
FuseML.
increase, Alex? Can you increase the
Absolutely
font size?
yes.
Yeah,
Absolutely yes. Okay, let
perfect.
me. That's
Yep, that's awesome.
installer install, and I'm gonna say also while you install, give me a couple extension. Uh, like Mflow, because I want to have the metrics for Mflow, and I want to have cave serving for basically publish the inference as a serverless. Now, why this is super important? For those that don't know what I'm doing here, like myself, I'm not really know what I'm doing. Basically, I'm just pretending I know. Actually, no, seriously. Now, MLflow is one of the most widely used tool to manage metrics and understanding of your models. It can do many things, but actually it is mainly there because you can write your own models, and then through MLflow you can track the model. And as a tracking tool, is super cool. KF serving, that is based on native, by the way, is a way basically to use serverless to publish the inference, to publish the prediction engine. Now, the cool point is that KF serving is from Qflow, probably the biggest open source AI project out there. There's no way actually to use KF serving with MLflow today. There's no automation. But if you use FuseML, we combine that. You can have MLflow and KF serving at the same time. You don't have to care about how to do so. Now, the second thing is that you will see, and I was starting to run, is that in order to do your job, you probably need to log in on each one of the underlying tools, because it's not just about optimization, it's also about maintaining infrastructure. So we take care of everything you need. I installed K3, the Civo cluster without traffic, without anything. Now, basically, what I'm doing here is that taking care, and you can see here on the first line, taking care of everything that I need there, like install Istio. Why Istio? Well, because in most of those tools you have to use Istio because otherwise they don't work. It's not really a choice. It's something like that. You got traffic, we recognize you have traffic. You got Istio already installed, we recognize you have Istio installed. Then what you need? Well, you need a Git repo. Maybe you're using GitHub, maybe you're using GitLab, but we need to sync that in the context of FuseML to take all your various things and install it. While you're using Gitty, and Gitty can be pre-installed on Civo. In our case, I don't find Gitty, I'm install Gitty for you. After Gitty, we need what? We need an orchestration engine. And what's the orchestration engine currently? Tecton. Again, Tecton can be pre-installed your cluster on Civo, but if you don't have it or you don't want to spend time in doing, we will take care of that. Also, because most of the workload using containers, we also will install a Docker registry to host your containers. And finally, we will add to that Kave serving native for you, and of course MLflow. And MLflow need a storage, or let's say, it need a storage area to save your artifacts. What about Minio? Most of those things can be pre-installed through Civo. If you don't want to spend time to pre-install them, we will install them for you. If you already installed them, not only on Civo, on your infrastructure, we will recognize them and use them all the way in. So basically, we are completely transparent. We are flexible. We simply integrate them. Now we're working on MLflow. Later, we will work on other integration like Katib, for example, or like the TensorFlow TFX components, and etc. That's why we're using, we are looking for contributors. And by the way, for everyone that actually is connected right now, if you like already what you see, go to the GitHub repo, put a star there. Let people know that you really like what you see. So the whole stuff is going there. I will not follow the whole installation. We'll let the installation go while we keep talking. what you will see, and you already see, is that, for example, I got a system domain. I never said what the system domain is. Now, when I created the cluster gave me a public IP. And I said, you as MLOps, eventually you want to have the capability to do what? To log in on the single tools, to do some specific customization, create user, and etc. As you can see, for each tools, basically, we literally publish the URL. There you go. It's automatic publish for you. You can immediately log in there. We have a default user as usual, that is the administrator there, and you can literally, and you can literally log in there automatically. There you go. And using it. I'm keep installing here. Now the register, after the register, they will install a Tecton. And as you can see, I keep doing that. I don't have to see nothing there. I don't have to learn nothing. From a theoretical standpoint, this is exactly how I'm using it. I'm using FuseML directly on WSL2. I'm using micro WSL2 because I'm product manager, I'm using Windows. You all know that product manager don't like Linux in reality. We fake that we are Linux expert, we actually. And don't say anyone at SUSE that I'm using Windows, by the way. Seriously, I'm using Windows. I'm leveraging WSL and running FuseML on top of it. This is literally, it mimic my, between brackets, production server. So I can literally start to build the pipeline, build the workflow, figure out what I need, how I need it, and etc. And once I'm satisfied, I just need to move the configuration file and run it. I switch the kube control, and that's it. That's all I have to do. You see that Tecton now is there. And once Tecton is built, again, you will see here that in a second or so, once you will understand the Tecton pods are running, I will get, as before, a URL for Tecton. And again, I will log in on Tecton and we see everything that I need there. And after Tecton, we will deploy the core component FuseML installer. And after that, we will also install Mflow and etc. 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 But you already know that actually it's pretty easy, because if I got these, then I know that if I simply switch these to Tecton, for example, I don't know if it's already there. It's not healthy yet. You already have Tecton, and then you can have Mflow and etc. 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 So I'm just waiting for Tecton just to confirm what I was saying before, and we will move on. So that's pretty easy. Once basically you're there, and you see actually we're working there. Let's just use these. I got the FuseML CLI, and the FuseML CLI is actually the real CLI I'm using to interact with everything. Basically, this is about create the code set, create the workflow, check the code set, I checked everything. So that means that I can say something like, I don't expect to have anything there, but FuseML code set list, and I can have an understanding how many projects I have, who is running where, what's the URL, so I can literally log in there or clone the project directly. The same goes for the workflow. I can do a workflow list, like give me the list of the workflow that currently has been created, or give me a list of the runs, and we will go through all of them during the demo. What is running right now? How long it takes? Or give me, I think this, yes. How many of these has been assigned? How many of these are dynamic integrated? Because maybe I just have, the workflow definition and I got the concept, but I don't need to assign them yet. So I have a full control over everything. Let me switch back. Oh, Tecton is there. Let's get back. So there's no fake stuff here and doing there. Oh, look, the Tecton dashboard is coming in. That's it, super cool. Did I have to run how to install Tecton? Did I have to run anything about Tecton? Of course I should, because in the end, I'm an op. But as an MLOp, this is just one of the many engines I'm going to use. And the same goes for Mflow. Once I will install Mflow, and you probably can see here, yes, there you go. let me just, okay, here you go. See, actually I'm installing Mflow now. How many tools were already installed? Git, Istio, Tecton, Mflow, Minio, Registry, the FuseML core itself. We are up to the 7th part. No friction, no fatigue, no complexity, just click. That's already available. And everything is set up that you know already it works. So while it keeps running, now you will see that in a second or so, once Mflow will be done, it will start to install native and KF serving as instructed before. And that's super cool. So we'll just finish this installation for a second, and then I will switch back to my local environment. And basically we'll just do this, the full rest of the demo there. Mflow is there, is creating Minio and etc. And then in a second, you will see it actually that it's starting to say me, okay, I'm done, starting to install native. And then after native, we'll install KF serving. So in a second or so, you should see appear here native and then KF serving. So that's the beauty. Now, right now is native, is KF serving, Mflow, but as I said, it could be any other tools. It's a recipe, basically. And because it's a recipe, you applied your favorite recipe to your context. And it's consistent, because that means also that you can have the same kind of approach to different instances of your cluster, etc. You saw native done, and now finally KF serving. Do you like so far, Sam?
Yep, everything looks so smooth.
Yep. There you go, KF serving controller, Istio controller, everything is being published. That also means that if I go to the virtual services, everything is being built as a virtual service. I can fully have control over that, and I can read that everything there. Okay, enough. Let me just double check the final. Native is being installed. Should basically appear KF serving anytime soon, I think. Yeah, it's only Cert Manager because it requires the certification manager as well. So you see, actually, I'm adding everything that I need, really. There you go, certification manager, and then after that, I will install KF serving. So I don't really have to care about anything. Still, I can configure everything. Still, I can have full control of everything. But if I'm doing local experimentation, or if I'm learning stuff, or if I'm just trying to understand what to do, that's all I have to do. And by the way, this is 8 gigs configuration, 31% of CPUs, 27% of RAM during the installation phase, so it's pretty slick. There you go, KF serving and done. And that's done. Then we're ready to use. And once everything is worked, as I said before, you got all the URL you need, as you can see. And at the end, also it tells you just these small things in order to use the FuseML CLI, go for FuseML server URL, and then I will check that for you. That's basically all you need there. Okay, KF serving is going there. Well, okay, I will stop here and then move it to the local user. So let's get back to our presentation for a second and get back to this. While I do this, I'm just moving this and I'm doing. So far so good. We said, okay, the first things was basically to take the concept, take the train, the prediction, set up the infrastructure. And so far so good. It seems pretty easy. And now I'm basically starting to say, okay, I'm a data engineer and a data scientist. And as a data scientist and data engineer, it's basically what I'm basically doing is just say, okay, I need an environment where to work on. That's my concept. So can you create an environment? So give me just a second. I'm going to, if you have any question, please throw a question while I'm basically just set up my environment quickly.
Yeah, but there's one. Can we integrate any other service mesh as an alternative to Istio with FuseML?
Yeah. For example, like I was using as experimental phase the Istio mesh as a part of that. Yes, absolutely. One thing that is super important, the project is really new. So if you have any ideas, more than a requirement, if you have any ideas and you want to add as ideas, please go through to the FuseML repo and let us know what you would like to see, because that actually is something that we really want to do. Okay, just a sec, and I'm done. Yes, absolutely. We have we also have a Slack channel in case that you can find on the micro website. So feel free to join the Slack channel and post question there, because we are absolutely more than happy to do so. So let me just check if actually, yes, everything is so far so good. Okay, let me get back to here. Let me just come back a little bit. Okay, so demo MLOps experiments. Let's start. First of all, what we got here. Under the code folder, I got basically already prepared before time a data folder that contains a set of prepared data set. It's split already between train, validation, and test, where I got the images. I will show you in a second. And under the model folder instead, I got actually my real file. To give you a sense of what I got here, basically this appears like that. So under the data, you got, and I'm using this really like a simple image. So you got a set of images here. These are the normal images. You got the opacity, like this is a bacterial. As before, I really don't see any real difference between that. The validation is, for example, is always this is a virus kind of images. So you see, basically, I've got a bunch of data set things. But this is local. This is right now is local. It's not really useful. And also, when I will act as a data scientist, we also have the train. So the first step for me is basically to create an environment. So create an environment means basically take something wherever it is and push it to the Git backend just to say, hey, by the way, this is what I'm going to do. This is what I'm basically doing. So the first thing is like to say, hey, FuseML, take a code set, register it under Git, and you can take it with the name experiment and within the project demo. And before going in advance, just to show you something, I'm going to this, and demo, as you can see, is pretty empty. There's nothing there. Okay, this is the local one. Let me just show up here. So where I'm taking things, I said I can use a URL in this case. I'm using my local. So I'm saying everything that is within code need to be part of that. But also says between that, I want to say also, well, put some labels there, like some tags, like machine learning demo X-ray. And also put, and also put a description like this is a cool demo around X-ray. Okay, so create an environment for my team so they can work on with the name experiment. The repo will be experiment under the project demo with all this stuff, and go there. Oops, sorry, what's the problem? Oh, label, not label, sorry. But you are a product manager, what do you expect? Everything works. Whoa, I'm doing okay. That's me doing this. Let's just use machine learning. That's enough. Okay. Whoop. What's the problem? Server misbehaving. Whoa. Okay. Let me just check my export. That's my environment. That's not FuseML. I'm sorry about that. Clear FuseML core, sim setting source. Okay. Yes, Let's try again. And this time it seems to work. Okay, dear demo goals, you try out. Good, but I'm better than you. So far, so good. What is happening? What I'm expecting to happening is that if I come here, let me just increase the font so you can see, everyone can see better, is that if I refresh this page, I should see something appear here. Oh, look, there's an experiment with this cool demo around X-ray and the tag machine learning. And when I click there, I should find basically everything that I just set up, like a README note, that's the first things. But once it will finish to push everything for me, I should find everything. Now, I'm sorry about the slowness, but this is my current bandwidth. Oh, it just finished. Let me refresh again. And this is exactly what I'm having. So I got a train file, I got a requirement txt if I want to install everything in my specific containers. I'm going to use Mflow, so I got an ML project, but also I got the data like we saw before, if I actually can click there. Sorry about the slowness. And let's take the test just to do there. And I got also the Kaggle, and I do normal, and I pick up one, and hey, there you go, the classical image. So everything is on set. Means now my user have a full Git repo. If they don't want to keep using any other Git repo, if they don't have anything, they have a full Git repo where they can version and they can work on the environment, so they can use this environment to test out everything. Maybe they're using already Git repo, so I just need to sync the stuff. But in this case, let's pretend we have nothing. We already have something that we can use. No friction again, full Git repo, everywhere it is, and I can use it. That's it. That's super simple. Cool. And if I need to pass this information to someone, then I can say FuseML code set list, and I will get the list of everything. Just let me do this so it's easier to read. Super cool. Now let's move to the second phase. Okay, now I'm the MLOp. They're working, just to finish and complete my configuration. They're working, they got this set of images, maybe they're working on a train, on the model training. In this case, I'm using TensorFlow plus Keras. What I'm doing basically, I'm taking this from Adik-Mook. This is a great repo from him, from a Kaggle competition. He built this TensorFlow model, and I got here, and I'm going to pass directly this amazing repo, because I think that people that do amazing stuff need to be really advertised more. I'm putting in your chat, Sam, so you can actually share with everyone else if you like. He has this great repo where he basically explain everything. So it's pretty old as a repo, the exclude classifier. He updated on the 23rd of June, by the way. But this one, it doesn't work out of the box with FuseML. This is really a standard demo. He's using H5 as a model. It's quite different. So I pick it up, rewrote a little bit to make it TensorFlow 2.5 aware. So it's updated to the latest version of TensorFlow. Actually, it's already updated because TensorFlow just released it 2.6. I need to work on that. But within that, you can have all the explanation of what you got here. So I'm just leaving you as a learning tool, so just to show you how many people are actually working around that. So that's okay. But what it does here is simply like train a model, save the model locally, and using it. This is not good for production. It will never work in production. This is not the way. It doesn't scale. We need to make it. And this is why FuseML is important. So first step, let's create a workflow. And in the context of FuseML, this is what the workflow looks like. So what we build is an agnostic EML file where you can describe the logic of your entire machine learning lifecycle, no matter what kind of tool you're using behind the scenes. Now, of course, this one is in the context of Mflow, Tecton, etc., because this is what I'm using today. But this is completely agnostic. It simply says, these are the inputs you're giving me, these are the outputs I want to have, and these are the steps in between. The input says, you get a code set, and I will look for the code set assigned from you. Eventually, you want to have a prediction. In my first experimentation phase, I don't want to have any prediction. I just want to have a training. So I basically comment out the prediction phase. And I want to have, in case of prediction and output, give me the prediction URL so I can actually make a prediction against. The steps are build a custom container that contains this stuff and run it, like the training part, and use it to do the training. So you put in the container that file and you execute it. And finally, into the media, by the way. And finally, if the prediction is exposed, use that to predict. And so use KF server in my case to do the prediction. Now, don't be scared. I know you see here my access key. Actually, this is going to be removed anyways, but those are not public access key. Those are within the context of my single minion instance. So you cannot use it outside of my instance. So there's no way actually you can avoid them. We are going to remove it anyways, but this is basically is just the way we are using minion. We're going to remove, but again, don't be scared about that. So the workflow is pretty simple. It says, this is how it appears. What we do is translate this workflow in something that Tecton in this case can understand. So I'd say, hey, FuseML, create a workflow from that definition. And what happened, literally in a second, is that in Tecton, now I got a full, let me just do this, a full EML file definition of a Tecton pipeline ready for me. Never learned Tecton, never wanted to learn Tecton, but it's there. So because my data scientist, data engineer are ready to train, I can assign it. And so I can say now, using my workflow list, and I see that the experimentation is there. But then I can say, let me just do a little bit builder. Okay, FuseML code set list, so I remember the names. Hey, FuseML, can you please assign that code set to that workflow? So give me a code set name, call it experiment. Give me a code set project, because maybe you have multiple experimentation phase with the same name but different project. Demo, along with the name experiment demo. Hey, wait a minute, Alex, where you pick up that experiment demo name? That is, if you notice it, the pipeline name that comes out of the EML file. So literally I'm saying, A, pick up the code set, name and project, pick up the workflow definition, combine them together so they can be triggered and execute them. What will happen is that, in a second or so, sorry about the slowness of my environment, in a second or so, you will see appear here a pipeline. And the pipeline will be executed through the steps of the workflow. I have not to, don't understand anything there. I don't have to learn anything there. Let's wait for a second or so. Should come. There you go. Here's it is. And if I look at the steps, those are exactly the steps I was explaining before. Clone the Git repo, build the container that contains them, execute the builder with all the flavor I place in there. Do you remember I have a requirement.txt file? Why is running? Let's check the requirement.txt files. What is the requirement.txt file? Oh, I want to use a specific version of TensorFlow. And in fact, when it goes to the builder, you will see that actually I'm installing TensorFlow. And then finally do the training for me. Oh, by the way, while we're explaining this, when you will go to the training, I expect that training to be linked to Mflow and show up in Mflow so I can actually evaluate everything. So let's check these. It's starting to build, it's using a specific small image, then it started to run there everything. For example, saying I'm using a vanilla Python image because I want to run a train Python stuff. Then I'm installing some stuff there like Git and etc. And then at some point, immediately after this part, I will see that actually I'm going to install everything for me. This is not necessarily the same behavior you will get. This is the behavior I decided I want to have because I decided to install that part in that specific things. And now in a second or so, you will see that actually I'm starting to install pip pip install. And in pip install, what I'm installing, Pillow, as explaining, and then I think in the second or third line, NumPy, and etc. And we see TensorFlow anytime soon. Seaborn, you remember that's exactly what I got here. Pillow, NumPy, Seaborn, Shippy, and then TensorFlow I should have. There you go. Both the three, scikit-learn. You see, exactly, I'm following exactly the same stuff. Again, I'm showing you those tools because I'm an MLOps. I'm deep dive into each one of them because eventually I want to customize them, but not necessarily want to go there. Now, while it's running, because I don't want to run out of time, while it's running, let's do a couple of optimization more. For example, while it's running, let's say that now, and literally, the pipeline is running, the data scientist, I'm doing directly from here just for that, decided to add a small optimization to his code, like, hey, why you don't use Intel TensorFlow? And literally is going to commit it. What is happening? I'm not touching anything there. You will see that, hey, I got a second pipeline here that is different from the first one. If I check that, when we will go to the builder, I will see actually that that pipeline has a different behavior. We'll install Intel TensorFlow. But I'm not going to stop here. I literally not stop here. I'm going to say another things. Hey, as an MLOps, I want to add a third flavor optimization, like using a specific Intel container. This is a recipe. I'm going to use the latest Intel Docker container to do so. So what I'm doing here is like, hey, you know what? I'm going to assign, I'm going to create a different pipeline definition called it Intel optimized. There you go. That leverage that container. And then literally, I'm going to assign same stuff. Sorry. Okay. Optimize it to that pipeline. Boom. Oops. I need to first unassign, sorry. FuseML optimized, experiment optimized. I think I got the typo somewhere. Give me a sec. Okay, FuseML was assigned because experiment with the name experiment optimized. Okay. Oop. Seems like he has some problem. Okay, it exists. Name experiment optimized. Okay, there you go. There was a typo somewhere. And now I got three pipelines running at the same times. One with the vanilla, one with experimentation with Intel TensorFlow, the third one with a full optimization there with one single click. I did not have to change one single line of code. I did not have to do anything basically there. That was simply pure godness from FuseML. So let's see what it does in the first step. So the first step should be almost there. Is installing everything for me. I think, yeah, it's basically done. Let's check out the second one. And I see there's a couple of questions, so I'm going to check those questions. There you go. We're almost there to install. In the meantime, yeah, I see that Stefan is taking care of some question about distributed training and etc. So I will leave to Stefan to do that. But as Stefan said, FuseML is really new. It's a really, really young project. We literally released the version 1 in June, and we're going to release a second one. And basically, so we welcome everyone to contribute. We welcome everyone to go there. So let's just wait another couple of seconds, and then basically we will see the training part. But again, this is an experimentation phase. I'm already up to a fully optimized version of that. And once I'm finished here, basically, I will see that everything will appear in the MLflow scenario. So I'm double checking here again. Okay, it's going there. I'm probably asking too much to my environment, but let's wait for a second. Is there any question so far? I see that actually, well, yeah, you mentioned AutoML too. Yes, go ahead.
Yep, there were a few questions that Stephen is taking care. So that's pretty cool. Thank you, Stephen, for that, for taking care of all the queries. And I think the product is looking really good. So there are a couple of comments like the you can focus on the core areas and leave all the all the deployment of all the tools, their integrations up to FuseML. So I think that's pretty dope, and it will reduce a lot of the slide that you showed, the fatigue of all the installation of tools, etc.
Yeah. So while we're waiting, let me come back to the presentation. I'm starting to do the conclusion, but I'm just at the conclusion because we're waiting actually the training to complete and then go to the prediction, just to not wait to look at stare at the screen. So first of all, FuseML can help you to avoid automation integrating into the lifecycle and manage the entire lifecycle machine learning. You can contribute and use it. It's free. It's open source. We are more than eager to actually to help you out to start with, etc. But we need a lot of help. We need stars, first of all. So while I'm speaking, I'm going to check literally the status of the stars. I left this morning with really few stars, and I'm expecting you guys actually to do an amazing job in adding more stars. Well, damn, I got just 1 star more. So people on the line like to put a star there. But actually, what is super important for us is bring your own ideas. In a form of a features, in a form of a simple idea, in a form of a question, even through Slack channel, please feel free to add them to our repos. This is exactly what we need to learn from you. We need to learn what you think of, what could be important. Maybe it's a tool, maybe, I don't know, maybe it's just something you learn from there. Maybe it's an example. I made the X-ray chest example that I'm coming back in a second. But maybe you want to see, I don't know, image segmentation, any kind of other prediction, some cool project. Maybe you tried FuseML and you did a FuseML. For example, if you check the example repo at FuseML, you will see that we got a linear regression with wine quality, with a full web app at the end, that you can use it as a starter. But you can add your own. So please do that. Okay, let's see actually. Oh, we got 42 stars. Literally, I'm checking live. Awesome job, guys. Really awesome job. So let me come back to here. Let's see what it does. Okay, I'm finished here and publish my first container to the registry. So anytime soon, I will see start the training. And when the training will start, literally, I will see everything that is happening. Now the training starts. I'm opening up here just to see what is happening, what I expect to happen actually. What I expect is that to see the training happening here, but also to see something appear here in MLflow. Because as a data scientist, I expect to see that. There you go. I got a 1 there, and I click there, and there's actually something that is going on there. And if I click on these, this is really pure MLflow, I can start to see stuff. So let me check my Tecton stuff, what it's doing. It says, hey, you're going to use this training algorithm, TensorFlow, with the batch size 16 compared to the images, but with 25 epochs. You got 25 rounds to learn around the images. Now, this is a demo, so I really have a few images, really few epochs to be fast. Otherwise, we will stare at the monitor forever. But you will see actually that I'm starting. I'm checking in the meantime what the other pipelines are doing. And you see, actually, I'm literally doing this at the same times on the same machine. And this is awesome. There you go. We are almost done here also with this image. And if I check this one, you remember the first one was standard TensorFlow. The second one, I'm just checking, should be at the beginning, if I remember right, here, more or less here. You should add, there you go, inter TensorFlow. So the second pipeline actually is using inter TensorFlow. And if I'm checking the last one, do you remember the last one was the one actually that is using what? The fully Intel optimized TensorFlow container. This is not just Intel TensorFlow. This is the Intel optimized container that if you got the Intel hardware underneath, it will fully use the Intel hardware, like the Ponte Vecchio CPUs and etc., etc., etc. That means literally you're using the latest capability of Intel. So it's 3 pipelines, 3 different behavior, 3 different optimization without having to change one single line of code. But it's not there. You remember, I'm keep running it. Let's check what the vanilla pipeline is doing. I'm just refreshing. Oh, look, it started to appear something like a sample of the prediction that I'm going to make. Just for validation purposes, I show you here during the pipeline that I'm able to read the images correctly and label them correctly. So that's the first samples. So let's get back to that pipeline. We are within the trainer. The training for Adik, the amazing job from Adik, written by me. Okay, we got 96 images. Actually, the original was 4,000 images, but it would take too much to train in a demo. So we saved some samples, what I just saw, and here we go. We're running we create a CNN, a convolutional network model, and here we're running the epochs. And we already see some loss and accuracy. So I'm basically evaluating the loss and accuracy. At the end, we will get the metrics with a nice line that show us how the metrics occurs. Of course, we cannot we pretend we are precise here. We cannot pretend we actually will get anything there, because that's not the purpose of the full things. It's more like show you a real prediction. Means literally my model is learning right now. Is literally learning right now about how much it takes and etc. And he's doing those things at the same times. So literally he's taking the second epochs and then goes there and goes there and goes there. And he's doing exactly the same stuff with the other. Second pipeline is starting to that. And in fact, if I come back to Mflow, now in a second or so, I will see another one here that it will be a second one that is running for me. So let's check when it will start here. And once the training will start, probably if I have enough resources on my laptop, we will see actually doing that, the things. Now, to complete the things where we are seeing everything, I'm going to stop the fully optimized here just to release a little bit of memory in my environment. I'm just let these two running, so just to show you that actually I got also the second run that is coming, which should come anytime soon. But I'm coming back as MLOps. Let's say that everything that I see once it will be over is okay. Now, what I would expect is that I want to go to the production, and the production basically is like before, but it has the prediction steps there. So what I'm going to do again is like, okay, everything is okay. And now, in fact, I can say FuseML workflow list runs. And now basically I will be able to see the runs that are currently doing there. And I can even say assignments. What has been assignment? One single assignment. So I'm going to do FuseML. Let me take that. That's one and assign it. Do again the list assignment. That's not working. And do something like that. FuseML workflow. Great, I'm not in experiment anymore, but FuseML, but I'm in production now. And so I'm doing, say, FuseML workflow, create workflow. No, this is an Intel optimizer full, means pick up also the prediction. Done. And then I can say something like, let me check how it's named. Production. And so we can say, okay, hey, FuseML, let's pick up the last one. FuseML assign now that we know that it works. Oh, sorry. But to the pipeline production. And what will happen, what we're doing is that the third pipeline again, but this pipeline will be completely different from the previous one, because this pipeline will have also the KF serving ready that will expose the trained model to the inference, so we can make a prediction to that. So while we're waiting, keep working on this. Let's see. In the meantime, there you go. We got the two pipelines as we expected before, and just we're waiting for the last one. Probably is my whoop. What's the problem? Okay, probably this is my environment that is too busy right now to assign also this. Okay, got it. Production ready. Check out. Prediction there. The predictor phase with the status and the details with the KF serving is ready for me actually to be published. So literally, I did not change one single line of code. I did not have to learn anything. I did not have to learn any tools. It's simply about the data scientist does his job, the data engineer does his job, the devs does their job. I, as MLOps, that I'm responsible for all this stuff, I can literally work with one single CLI here. Paste, runs, and I know what's going on there. And I see if it is complete, the duration, if it started, if it's failing, if there are any problem. I can literally overlook to the whole stuff there without having a single line of problem. So basically, this is the end of the tools. I'm just waiting for Mflow to complete and see there. So I'm just spending time if there are any more questions or many more things to explain everything. We are almost there, I think. Yes, more or less. In case I will basically just stop some of my tools just to show you the training. There you go. The training is going there. I think it will take a little bit more long. Yes, it's 5 out of 25. So I'll probably pick up too many epochs for my environment. So let me just stop those two so we can complete them faster than before. There you go. Going there, ready to make at the end you will see actually I'm making the prediction directly in the training just to skip a little bit more time. Cool. Any question, anything? Do you like what you see, guys? Do you have any question? Do you want to start immediately with FuseML and give a try and see actually what is happening? Oh, thank you, Abhishek. We really thank you. Yeah, everything, all the things need to go really, all the kudos need to go really to Stefan, now the main architect of FuseML. He did an amazing job in literally inventing FuseML and bringing it to life. To him, to Flavio, to Giri, the amazing team behind FuseML. This literally, you can't believe that, but this literally is a project made by 3 people and a noisy Italian PM that is pretty useful. So they kudos to them. And Sayam, as usual, to all stars, because without you, actually, we cannot miss anything. Okay, we're going there. I'm just waiting for a little bit more time, and then basically we will wrap up doing that. While we're waiting, again, I'm just give you the pointers and bring you ideas, and then basically we'll read there. Sayam, any more comments from your side?
No, I think the product looks super cool. Just as Abhishek also mentioned. So it's basically focusing on just your particular use case, and rest all things are falling in place automatically. So the pipelines are coming in place, so the training is coming beautifully in place. So I think that's pretty dope, and
Yeah.
I think it's and it's the first release only that has been done. So with that itself, it looks a lot promising.
Yeah, and I show you something that I was noticing right now. But that's exactly again explain why MLOps is so hard. Take the estimated time here. So, of course, my environment is pretty limited right now, and of course, basically, it's consuming a lot of effort because I'm streaming right now while I'm using the same environment and etc. and etc. etc. But if you look at the estimation time, how they vary depending on how you do release the resources there. And this is, unfortunately, it impact the accuracy and the loss. Now, just to give you a little bit more information, what's about accuracy and loss? So the model basically has not just those two, but let's say two major metrics in this case: the loss and accuracy. So how much you lose in terms of capability to recognize correctly the image in our case, and how much you're accurate in terms of recognize the image. The sum of those two basically allow you to predict correctly the images. So once we will finish, basically you will see that actually I'm doing what? The training using the train images in the folder. The validation, basically using the validation to say, okay, if that is what I think it is, that is the results. Means you will see that I have an image, basically that shows how many of those images correctly has been predicted versus how many images are unfortunately false prediction, and how many images are recognized as real versus not real. That gives me a sense how much my model works against the unknown, against whatever will be thrown to it. Then I will try to make a prediction there. So this works from a data scientist perspective. This is why I'm using Mflow. I'm just waiting Mflow to complete. This basically will give you the sense of Mflow to tells you, okay, my model works. But when you go to production, when you go to prediction, as we saw before, that I push the full pipeline and then I basically get the full prediction, you are basically predicting against unknown images. So over time, your model, because of many things, can lose this accuracy and increase the lostness. And that basically is where you should basically retrain the model. But that's part, there's some tools to allow you to do that, like Seldon Alibi, like some of the TensorFlow tools and etc. But that's part of your job as MLOps, is understanding when it's time to retrigger the training and why you really need to know that. Because the problem is exactly, there you go, we basically complete. Because the problem is that training is a cost. Training requires a lot of hardware, especially GPUs, and is a cost for you. So you only should train when it's really time to do so. There you go. I'm basically testing the accuracy. Accuracy is 68%. And now I'm basically finishing here. So basically, if I come back here, I should basically see everything is been done. So now see, I got the metrics finally. And if I check the metrics, now I got, for each steps, I see how the metrics actually, it appears. And I can even compare these to my loss. So basically, they should basically divert. So they start to, you see actually like accuracy and loss. You see at some point, I'm going down. This is where I'm become precise because they divert. It means I'm having not lost a good accuracy. But we can do, I said, I for the sake of the presentation, I made even something better. This is the confusion matrix. So actual normal images versus predicted normal images. Actual polynomial images versus predicted polynomial images. How many of them were really predicted correctly versus how many of them I missed? I missed 8 images out of the 96. I missed 26 out of them. That means that I'm not for sure very precise, but I try to make a prediction. And the prediction, sorry, this is really small. Let me increase that. It was saying, okay, I'm 77% sure that image is a polynomial case. And actual, yes, that was the image. I made it a prediction. That image that I recognized, I was able to tell to the medics, hey, this guy here, this folk here, he has a polynomial. You have to check it out. That was actually the prediction we were placing. Now, this is just a training because I can pick it up what the model that I trained, the TensorFlow model that I saved, and published directly to the inference as we saw before. So job complete. In a second, well, it's a little bit more than a second, but literally we were able to do everything from scratch, from a pure data set up to a point where we can serve this model to the inference and make it a real prediction against a real application, or even just stop at the training and do that. And if I run now the other pipeline, as we saw before, if you rerun them with optimization, we will basically see that the accuracy, the lines here in the accuracy will increase even more. We will have full optimization there. And you can test it on your own. You can literally test it on your own because that example will be public in our repos pretty soon. You can rerun the same matrix and the same example pretty soon. And with that, basically, I'm coming back to my last slide. I'm basically wrap up here, and I hope you enjoyed what you saw before. And if there's any other question, I'm more than happy to answer them.
No, I think that was an amazing demo, an amazing explanation of the tool, walkthrough of all the features, and showcasing a complete end-to-end training model demo of how the pipelines work, how the actual graphs would look like in the end, how the overlaps will happen, and eventually the accuracy will increase as your training data increases, as your all these things increasing. So yep, that's pretty amazing. Thank you, Alex, so much for your time. It was really insightful. I think people will definitely get benefit from this particular stream, and
Yeah.
even from the start till the end, and with the end-to-end use case demo. So definitely, I mean, you should all check out the repository and give a star. So definitely check out the repository and give a star. It's pretty new project, and pretty easy to get involved at this particular stage. So get involved with the team. They are building something cool out there. So definitely try that out in the MLOps space, AIOps space. So I think that's pretty cool. So thank you again, Alex, for tuning in and sharing all your knowledge and information with us. And thank you, Stephen, for being in the chat from start to end and answering all the questions. Really appreciate that. And thanks to the community for staying till the end. I know it's bit extended, but I think it was going in the right direction. We were discussing something pretty new, pretty interesting, so it was cool. So thank you all, and see you next time.
Thank you. Bye.
Bye.